BRONSTED-Lowry theory. We have already learned Arrhenius theory. On Arrhenius theory, definition of acid means the ones who ionize a H plus ion. The theory, what is a base? Who ionize a OH minus ion as a definition of acid and base. Arrhenius theory apply only to aqueous solution only. So remember what Arrhenius theory define acid. It will ionize a proton in water. So when you put acid molecule in water, they will become ionized. So this apply only in aqueous solution in water. Does acid react in the air? Arrhenius never answer. And Arrhenius theory also have an important limitation. That is, he finds certain substance as ammonia NH3, as Na2CO3, sodium carbonate. They are a base. But these two bases, how come you don't find a OH? If you cannot ionize a OH, how can you be added as a base? But experiment prove this is a true base. So what's the explanation? Now it comes to BRONSTED-Lowry theory to explain. On BRONSTED-Lowry theory, acid-base definition is talking about transfer of proton. So what is meant by acid? Acid is the one who donate proton. They give out proton. If you compare onto the top theory, it's very alike. What is a base? The base will be look very different. Instead of donating OH minus, base means they accepting proton. Accept proton as base. And this is an important theory. Please remember and understand. We have previously learned Arrhenius theory defines strong acid, which they will become, this molecule will become ionized as a H plus and a OH and a negative ion. Weak acid also the same, but they have a reverse arrow. So that's the difference between strong and weak acid. Now let's look on to BRONSTED-Lowry theory when he defining weak acid. He say, depend your point of view. If you look from this point of view, this acid molecule will become a H plus ion and a negative ion. But if you look onto the reverse point of view, this negative ion will accepting a H plus ion and become a molecule. So this is a base as accepting proton. Base means proton acceptor as BRONSTED-Lowry defined. So in a weak acid, it can be an acid, also can act as a base. BRONSTED-Lowry theory is a very common in all the weak acid. As you see in this example, this acid will easily donate its H plus ion to its partner as follows. But once they donate the H plus ion, they also tend to take it back. And so a weak acid can donate and accept a H plus ion at the same time, and which apply to, for example, acetate react with water. Same story. They will donate the H plus ion. But once they donate the H plus ion, they will tend to get it back. So this is the behavior of the weak acid. In this behavior of weak acid, students will struggle about formulating the equation. To do the equation, that is a rule. Rule number 1. You define a conjugate pair. Conjugate means a mirror. So this is the mirror pair. And so in the mirror, who do you see? You see yourself. You don't see your partner. So this is a mirror pair of its own itself. Another conjugate pair, this is the mirror pair. So once you define two conjugate pair, rule number 2, you want to find out which one is the acid or base. Rule very simple. Whichever inside within this pair, whoever have an extra H means acid. Within the pair, whichever with an extra H means acid. So in this pair, you can see this one have one H more. So this must be an acid. The other will be your mirror base. And how about the other pair? As this one have one H more, so the other must be the mirror base. That's the way you define, and that's the way you identify equation of double arrow, specially apply or weak acid. Please learn this rule. Now let's see if you can identify are the equation correct or not. Try first one. Conjugate pair first. Within the conjugate pair, one H more means acid. Within the conjugate pair, one H more means acid. So this base react with base give an acid and an acid. That's wrong. Try second equation. Conjugate pair. One H plus means acid. One H plus more means acid. Again, this is wrong. One more. Conjugate pair. One H more means acid. One H more means acid. Base react with acid give acid and a base. This is correct. Now let's do another example. Conjugate pair. Extra H means acid. Extra H means acid. Wrong. Next question. Conjugate pair. Extra H means acid. Extra H means acid. Again, wrong. Last one. Conjugate pair. Extra H means acid. Extra H means acid. That's correct. Student, this is the way you're identifying the conjugate pair. Is the equation correct or not correct? Of this conjugate pair rule, it is not only limiting to identify you are doing the correct or wrong equation. Actually, you can use this rule to construct a whole equation yourself. The rule as follows. Now let's try a few weak acid and a weak base. Let's start the first one. Ethanoic acid, number one. Ethanoic acid in water. What will it form? Ethanoic acid is an acid. So water is a base. So identify your mirror pair, conjugate pair. So your mirror pair must be a base, must be 1H less. Water. Your mirror pair must be 1H more acid. Next question. Carbonic acid is an acid. So your partner must be a base. So identify your conjugate pair. Your mirror pair must be 1H less. As to water, being a base, your mirror pair must be 1H more. Last one. Ammonia. Ammonia is a base. So ammonia as a base, your partner, water, must be acid. So identify your conjugate pair. Your conjugate pair base, you must be 1H more as an acid. Water, your S as an acid, so your mirror pair, the mirror pair must be 1H less. So OH 1 minus base. Student, there's another factor I would like to highlight. Students find this rule should be easy, but students always have problem on identifying the valency. Like NH, like acetate, they are 1 minus. 1 minus. HCO3, 1 minus. How about CO3? 2 minus. Student, please remember. Ammonia, NH3, no charge. NH4, 1 plus. So OH, 1 minus. So student, please get yourself very familiar with the charge and the valency, so that in order for all the topic that you learn. Thank you.